So today's lesson's on 6.4, rational exponents. Our objective for today is to simplify expressions with rational exponents and write radical expressions as an expression with rational exponents. Those are two different objectives for today. We'll demonstrate that on the exit ticket, the quiz, the unit test. When we're talking about rational exponents, that just means that, remember, rational just means fraction. All right, so all we're talking about is when we have a fraction as an exponent. We've talked about it a little bit before, kind of passing about how we can change an index into a division part right here and vice versa. We're going to be going more formally into that today, where we're going from here to here and here back to here. All right. Clear all that. We'll do a little bit of problems where it's more basic, where there's just one thing that we're going to be doing and some simplifying. Then we'll go into problems where we have to multiply, divide, all that type of stuff. And then we'll use some ones where we have some actual numbers instead of just variables and everything, right? Where we're simplifying completely. Then we'll have a you-do problem down at the bottom where we'll check to see if we understand what we're doing before we start our exit ticket, or we'll test our knowledge. All right. Let's go back up to the top, the we do practice part right here. We have a couple of these through here. Some of them are very simple. Like A is very simple. All we have to do is notice that we have this formula. We want to write it in radical form, which means we want to write it in this form right here. And so we take that 7 and we put it as our index. So that's 7 right there. It's placed right here as our index. And then we're done. That is changing something from rational exponent form into radical form. Right? Very simple. Don't need to overcomplicate it. That easy. Now it gets a little bit harder when we have something like this, because this can be simplified. All right, so I'm going to show you two different ways to simplify this. One way is to simplify when it's still a fractional power. The other way is to change it into exponent and radical form and then simplify. Okay, so first thing I'm going to do is I'm going to break up this 8/7 into a whole number. Right? So 8/7 can become, show right here, 1 1/7. So that's where the 1 right here comes from, and the 1/7 right here comes from. So that's how we change that into this. From there, we change this 7 back over to the front. We do right here. So this is our answer right here. W times the 7th root of W. That would be it in simplest form right here in my radical form. Are there any questions on that way of doing it before I show you the other way of doing it where I switch right away and then simplify? Change up how I ask. What questions do you have? All right, we'll move on to the second way then. We got our or statement. We can rewrite it right away as that fraction. Then we can simplify from there. Just like we did earlier today with our warm-up, we can change this 8 into 7 and 1. That's 7 W7th to the 7th root cancels out. So we end up with the same answer in the end. All right. So the process is pretty much the same in both ways. It just depends on whether you want to simplify it using fractions or simplify it using the square roots. All right. Those are my two ways. Does anybody have any questions on this second way of solving? Or not solving, simplifying should be the word I use. Remember, I won't know if you have a question unless you tell me. Can't know unless you give me, some type of warning. All right, to make sure people are paying attention, which way do you like better? Do you like way 1 that we did it, where we kept it as fractions, simplified, then switched? Or way 2, where we switched first and then simplified? All right, so the first person said way 2. That's currently winning. A lot of 2s. A lot of 2s. 1, 1 so far. Still more 2s, still more 2s. All right, another way 1. I like that. Let's cut off the thing. Sounds good. So a lot of people seem to like way 2 better. Then make sure you focus on that way. It's completely fine. You can choose either way you want. It just depends on which one you like better. All right. Let's move on to example 2 now. Rewrite in exponential form, which means that I'm going to rewrite it in this form right here, m over n. All right. So first thing I can do is I could simplify right away, just like we did up here. You can simplify first. Rewrite the a to the 5th as a to the 4th times a, because we have that invisible 2 out front. That's not what I wanted. Which gives me, oops, I don't actually want that. A squared times the square root of a. And I can change that square root of a into a to the 1/2 power. And before we move on to the final answer, I want to kind of show that, because there's a lot of invisible things with the square root of a that we don't actually see. Right? The square root of a has a bunch of invisible numbers all around it. Like over here for an index for invisible index is 2. And then my invisible power up here is 1, right? And so when I change that over, I get a to the 1/2 power. So that's how that kind of works right there. The square root of a has those invisible numbers of 2 and 1, and then change to 1/2. All right. Combine them into one thing, and I get a to the 2/2 power. Now the other way to do it is to change it over right away, simplify, that'll be your answer. In this case, it's probably easier to switch over first, because you don't have as much combining and everything you have to do. That's up to you. Are there any questions on number 1, either the first way we did it or the second way? Again, the 1/2 comes from this right up here. The square root of a has some invisible numbers around it. Remember, when we have the square root of something, we have that invisible 2 that we don't actually write out, but is always there. And then if we have something like a right up here, we have an invisible exponent that we don't actually write down of 1. So that's where that 1/2 comes from. Right? Just like over here, when we had that w right here, turns to a w right there, there's an invisible 1 up there. All right? There's always that invisible 1 if we don't have anything. Does anybody have any questions more on that 1/2 part right here? Anybody confused on where that comes from? And someone asked about the second way for this one. There's that, again, in that invisible 2 right here. All right, we got to remember that. That seems to be something that a lot of you are forgetting. There's an invisible 2 whenever we don't see that number out front, whenever I don't see my index. So I move that to my denominator, just like so. And I get 5 over 2. That is my answer right there. 5 halves can be simplified to be 2 and 1 half. Okay. Do it just like this. 2 divided by 5 is 2. 4 gives me 1 with a remainder of 1 over 2. 2 and 1 half. All right. Does anybody have any questions on this? Anything I didn't explain well that you want me to re-go over? Anything you want me to repeat? Anything at all? All right then. Let's move down to the last one. This is another example of one that's actually pretty easy. I just move the 5 to the denominator, and I'm done. Because 3 over 5 cannot be simplified. So that'll be my answer right there. Are there any questions on number 2 from example 2 before we move on to our next section? We move up, we upgrade our problems a little bit, make them a little harder. All right, let's move down then. We have a couple properties of rational exponents. We've gone over these before in a previous unit. Let's do some reminding. The main ones that we're going to be using are this one right here and these two right here. Those are going to be the main ones we use when we're simplifying radicals, right? This one says whenever we have the same base right here, we can add our exponents. This one says whenever we have a negative exponent, like we did this morning for our warm-up, we can move it to the denominator. This one says if they're on opposite sides of the fraction bar, we can subtract them. And then here are some examples of how that kind of works. Does anybody have any questions about any of these properties or these examples? All right, then. Let's move on to down below where we're talking about actually using these properties. For number example 4 right here, simplify the radical expression using the properties of rational exponents. Notice that it says write in radical form, which means that I'm going to end up doing some work in fractions and then I'll write it back in radical form. Okay. So for this first one, I can switch it over to fractional form right here. Remembering that there's that invisible 2 right here. And so I have that invisible 1 right here and here. So this becomes 1 over 2, and this becomes 1 over 4. I add those two numbers together, 1/2 plus 1/4, which gives us 3/4. Now, like the problem says, I should rewrite it in fractional form. I'm going to do that down below because I kind of ran out of room and I didn't want to have to do some juggling. All right. So, any questions on way 1 of getting our answer before we move on to the second way of doing it, where I change after I simplify, after I combine? All right. So I start with this right here. What I need to do to be able to combine them. So the 2 is just our invisible number. That's always what we have there when we are just expecting nothing there. All right, whenever it's because it's called a square root. So that's our symbol for square root. We just leave that blank whenever there's a 2. Right? So there will always be a 2 whenever there's nothing there. Just like there's always an invisible 1 exponent when there's nothing there. Right? That's something that we're going to have to memorize because there's no real trick to learning it or anything. You just kind of got to memorize it. Right? Whenever you don't see a number, we're going to make it a 2. Now to make these match right here, this 2 and 4, I need to multiply this one right here by 2. But if I do it to 1, I have to do it to the other exponent as well. And so I get 4 out front and 2 down below. All right. Now I can combine them since they have the same index into 4 to the 3/3 root. And then technically, since it wants me in radical form, I'm already done with this problem right here. All right, since it already wants it in radical form, this would be my answer. But just to check to make sure I got the right answer on the other one, I did reshape it into here, make it as 3 to the 3/4 power. Right? But technically, since the problem asked for it in this form, this would be my answer, and I would leave this out. Because it asked for it in radical form. Right? So both ways work. You can do it in this way, then change it into this, or do it to this way and change it into that. Right? Are there any questions on A, either the first way we showed it or the second way, before we move on to B? All right. Make sure everybody's paying attention still. Seems just so everything's quiet. Which way do you like better, number 1 or number 2? Please put it in the chat. Getting a lot of number 2s. Got a number 1 again, number 2 again. It's a reversal of my last class. A lot of my students in my last class like version 1 better. All right, number 2, number 2, number 2. A lot of number 2s. Sounds good. Let's move on to B then. B, again, we have 2 different ways that we can do this. I can change it into fractions like so. Invisible 2 right here gives me divide by 2. Since they're on division bars, we subtract them. We get 2/3 minus 3/2. 2/3 minus 3/2 becomes 4/6 minus 9/6 because I want a common denominator. So I multiply both of these by something that'll make it common, which is 6. Subtract them, and I end up with this is my answer. Remember that whenever I have a negative exponent, I need to move it to the denominator. Now this would be actually an incorrect answer right here. We'll see why in a second. And we can see why we might run into a problem in a second. All right, for the or, the second way we can do this, I make them the common denominator again, common power of 6, which means I need to multiply both of these by whatever they're missing. This one's missing a 2, so I multiply this by 2 and 2, and then 3 and 3. Now they have the common 6, so I can combine them into 1. That's not good. And then divide them. Right? I do some more simplifying, and I end up with this right here. Now you can see that these are going to match, but since I want it in radical form, I should actually leave it in this form right here. Now this is a little thing I want to check with everybody. Why isn't this a correct answer? What is wrong with this answer that makes it wrong? Anybody tell me why this answer right here that we got right there is not fully correct? Perfect. I got one person with the correct answer. Perfect. I got two people with the correct answer. 2 for 2 so far. Anybody want to make another guess? Perfect. So there is a radical in the denominator. I can't have that. All right. That's not allowed in our math to do that. So I have to simplify this a little bit and make this into the same thing. So I'm going to give this a little bit of a different thing. I'm going to rewrite this as 1 over the 6th root of x to the 5th. I'm going to multiply top and bottom by whatever it needs to be matching. So I need another x right here to make this 5 plus 1 make a 6. Excuse me. If I do it to one side, I have to do it to the other. And so my true correct answer for this one wouldn't be this, but it would be 6 root of x over the 6th root of 6x, which is then equal to the 6th root of x over x. And that would be my final answer right there. So I'm going to erase this circle right here, and I'm going to box this answer up here. My true final answer shouldn't be that. I rewrote this. I didn't want to actually. Backspace. Insert equation. It's always annoying when it does that. Equals. I need to actually make this all this way. Equals fraction bar, nth root of my 6, x over x. And that is my true final answer right there. Right here. Are there any questions on B, on that final answer, before we move on to example 5? Give you a little bit of time to think it over. All right, then we'll move on since I don't see any questions. Clear all drawings. We'll move on to these ones down here. For these ones right here, it's very similar, but these problems are kind of problems that I've made to be able to be simplified into a nice number. Right, so we're going to be getting rid of the exponents. Right, so this one can be rewritten as 16 to the negative 5 halves. This negative 2.5 can be rewritten as negative 5 halves. And then I'm going to rewrite this as the square root of square root of 16 to the negative 5 power. The reason I can do that right there, go from here to here, is because of this invisible 2 right here. Right. This 2 became my index, just like we've done before. The square root of 16 is a nice number of 4. 4 to the negative 5th root is 1 over 1024. I will say this, that's a little helpful hint for everybody. If you, right here, if you try and put this as a decimal, you will be marked wrong on this problem. You must give me your answer as a fraction like this. I'm not testing on whether you can plug this into a calculator and figure out what it's equal to. I'm testing on whether you can simplify using your radical form, simplify using your different properties of exponents to slowly get this answer. All right, so giving me an answer as a decimal doesn't show me that you know what you're doing. All right, so you need to give me your answer as one of these fractions. Are there any questions on C or what I expect out of an answer of a problem like C? All right, let's move on to D. I don't see any questions. Same process right here. I can rewrite negative 32 to the 4/5 power as the 5th root of negative 32 to the 4th power. It turns out that this right here actually can be simplified nicely. Not that whole thing, but there we go. That part right there can actually be simplified quite nicely. Turns out the 5th root of negative 2 is just 2. And negative 2 to the 4th power, negative 2 times negative 2 times negative 2 times negative 2 is 16. So it becomes a very nice answer in the end. Now, if you don't know that 2 to the 5th power is negative 32, that's fine. You'll just have to use a calculator to figure out if it's 5th rootable, all that type of stuff. That's about it. If you're wondering how to do that, Google's calculator actually doesn't. If I spelled that right. There's calculator.net one or any scientific calculator has a button on it that says y to the square root of x, where it's different every time, but most of the time you put it in your number that you want square rooted. Click this button right here. This will be a second function on most calculators. And then you plug in whatever number you want out front, a 5. All right. You have to use this button right here to be able to properly do a 5th root. Got to make sure to use that number. So we get negative 2 in the end. All right. Again, y to the power, y to the square root of x. That's how I do it. All right, I have a question for everybody. Someone asked me this last class. I want to see if anybody can tell me the reason. I had a negative in the exponent here and it just moved it to the bottom. Why didn't this negative right here move it to the bottom? Anybody tell me the reason why this negative didn't move it to the bottom? It's kind of a weird question to ask, but I want to see if anybody can give me a good reason. Why didn't this move it down to the denominator like this one over here did? What's different about these two? It's a perfect answer right there. Anybody else give me an answer? Perfect. It's very simple. Someone said it perfectly. The exponent for D isn't negative. All right. Some people started getting confused in a couple of my classes where they tried to, whenever they saw a negative, flip it over and make it positive. We cannot do that. It's only if my exponent's negative that I can flip it over. All right. This is a negative 32. This is not 32 to the negative first. I repeat that because so many people make that silly mistake and I don't want it to happen to you all. All right, so I want to repeat to you all. I only flip it like this if it's a negative exponent, not just because it's a negative and we're dealing with exponents. All right. That simple. Are there any last questions before we move on to the you do problems, and you are free to work on all that stuff? All right. The you do and the exit ticket. Any last questions from anybody? All right. As usual, I'm here to help. Let me know if you have any questions at all. Happy to help, always here, and good luck.